After very exciting nuclear fusion, I'm here to talk about anaerobic digestion. And my name is slightly more older, more simple technology. My name's Quinton Fivelman, and I'm from AdFerTech. So now anaerobic digestion is a process where one takes biomass. It can be any organic feedstock, such as food waste, animal slurry, or manure. And anaerobic digestion is a process whereby it gets broken down into biogas, heat, and also digestate. Now, I'm going to focus on digestate because this is actually a massive problem. Digestate actually lands up being 80% of the volume that goes in, comes out, and most of it comes out as this liquid. A lot of it comes out as the solid fertilizer, which can be used as a soil improver or fertilizer, but most of it comes out as this brown liquid. It's a bit like the liquid that, when your veggies go off, you get that brown liquid at the bottom of the cellophane bag. It's sort of like that. And so this is a problem. And how do we get rid of it? Well, normally the liquid digestate is spread as a raw liquid fertilizer on farmland. So farmers often use it and spread it. However, there are lots of problems with this. First, it can run off and pollute watercourses, which causes many, many problems. And you cannot spread this liquid fertilizer onto waterlogged fields. This is incredibly important at this point in time because with all the heavy rainfall, many AD farms cannot spread the liquid digestate. And with spring approaching, this is going to become a massive problem. It's also very costly to dispose of in wastewater treatment plants. So this is really becoming an issue. And also it's very expensive to transport, move around, and store. One needs huge storage facilities. Now, the problem is AD's really booming in the UK and worldwide, but this problem of liquid digestate is actually holding it back, and it's having a massive problem. And with the increased AD, this is going to lead to even further problems. We have the solution, AdFerTech. It's a device, this bolt-on low-cost system that can convert this liquid waste, not the solid, that's easily separated, but the liquid waste into value-added fertilizer, which is granular, so it can be spread onto fields. This is a patent-pending system, and it can be used on new and existing AD plants. It can be retrofitted too. It can work on any sort of feedstock, and so that means any liquid coming out with any food going in can work. At the moment, there's no commercial way to treat this digestate. So really, we see this as a real open market. The products can be stored or used later. It can be transported around, so it's obviously far easier to keep. And also, it can compete on a nutrient basis with normal fertilizer, which allows for cost savings to the farmer because they don't have to use as much fertilizer. Also, this is obviously a very low carbon way of making fertilizer. Synthetic fertilizer is very intensive and uses up a lot of carbon. Also, this very much helps the phosphates and other nutrients be recycled back into the fields. So you're really here pushing a pure circular economy product. And there are many benefits to do with this. This is the team. There's our head scientist, Chi. These, both Chi and Gavin are both based at Queen's University in Belfast. And they're both experts in chemical engineering, and also both of them work in specialists in, say, adsorption of nutrients from various liquids. We also have, so I work on the commercialization side. My background's in technology assessment. We also have a mechanical engineering team, as well as an experienced anaerobic digestion team. And altogether, we're a consortium which is putting together the prototype at the moment. We've also won numerous awards. And these are some of our partners here too. So the opportunity at the moment, well, the UK's got about 250 AD plants at the moment. About 200 are in planning at this point in time. Last year saw 43% growth in this industry. Europe, on the other hand, has 7,000 plants, and this is a $3.6 billion market, which is really growing. So you can also see the opportunity to have one of these devices fitted onto all these plants. We've been very fortunate with funding. We've won a fully funded Greenius Award from the TSB, as well as had Invest Northern Ireland grant funding. And our next steps, where we are at the moment, is using the funds to build this prototype system, and we're going to be testing this on a fully working AD plant, the largest one in Northern Ireland. But we're very keen to test this all over the country. We're also going to be filing additional patents and also going to be initiating mass manufacturing. As you can see, there's a lot of potential here. We're looking at a 28 million pound profit within about 5 years when we first start selling our device in a year's time. At the moment, we're looking for a seed investment of 150K, and this will be followed by a 350K first round investment. Thank you.